81 search in rotated sorted array number 2. There is an integer array nums sorted in non-decreasing order and not necessarily with distinct values, which means we might have duplicates. Before being passed to your function, nums is rotated at an unknown pivot index. So for example, if this is the sorted array that we have, it has been pivoted at index 5, and this is what has been passed to the function. Given the array nums, after the rotation, an integer target return true if the target is in nums or false if it is not. You must decrease the overall operation steps as much as possible. So the easiest way to approach this is just the brute force one. We start iterating from the beginning of the array. We check all the single element and see if it is equal to the target, and if it is, we are going to return true, otherwise we return false. So that's very easy, but the time complexity is going to be linear. But there is a better way to do that for finding a number. What we can do, we can use a binary search. So let's see how we can solve this problem. First, we are going to use binary search, and we are going to have 2 pointers, and also we are going to have a mid pointer as well, right? That we can use to compare the values that we have at the right pointer and the left pointer with the mid pointer and decide on moving the 2 other pointers. So, and then we are going to compare mid with 2 pointers and make decision on moving them, right? So let's see how we can do that. What we can do, we are going to have an I pointer and j pointer. It starts from index 0, and the j pointer starts from the end of the array, which is going to be the length of nums minus 1. Then I'm going to say while I is smaller than j, so it means we are within range, we are going to do a few actions. One thing that we need to keep in mind is that we might have like duplicates numbers, and we need to deal with that like at each iteration. So I'm going to say while I is smaller than j and nums I is equal to nums I plus 1. So it means we have a duplicate. What we can do, we are going to move I 1 step forward. Also, I'm going to say if I is smaller than j and nums j is equal to nums j minus 1. So the same thing, I'm going to move j 1 step backward. After dealing with these like duplicate cases, what I'm going to do, I'm going to say I need to find the mid index. I'm going to say I plus j, and we should put it in parentheses, otherwise it's gonna do the division first and then summation. So I'm going to do the division, and first thing I'm going to check if nums is equal to mid, and if it is equal to if nums mid is equal to the target, and if it is equal to the target, there is nothing else to do. We are going to just return true, and that's it. That's the easy case. But what if the nums that we have at I is smaller than the nums that we have at mid? So in this case, if the value that we have at index I is smaller than the value that we have in mid, we are going to check 2 cases. The first case is when the target is within range of the I and mid, right? So I'm going to say if nums I is smaller than or equal the target, and target is smaller than or equal to nums mid, which means it is within range. And if it is within range, so it means I need to move the j to mid minus 1. Why mid minus 1? Because I have already checked mid condition, so I know mid is not the answer, right? And otherwise, so it is not within that range, so I'm going to move I to mid plus 1, right? And if the value that it's in nums I is not smaller than mid, this is going to be the other condition. I'm going to check if nums meet is smaller than or equal to target, and if target is smaller than or equal to nums j. So I check the right side. Now I check the left side. I'm going to check the right side, and if it is within this range, what I'm going to do, I'm going to move the I to meet +1. Otherwise, I'm going to move the j to meet -1. And if we have traversed the whole list and we couldn't find the target, we are just simply returning false, and that's about it. So the time complexity for this is going to be, oops, there is a typo here. The time complexity for this is going to be linear for the worst case, and for the best case is going to be logarithmic, because at each point of time we are going to traverse half of the list, and the space complexity is going to be constant because we are not using any extra space. Thank you.